I am Anil Kumar. Welcome to my series on exponential functions. In this video, we'll discuss a very important question where we are going to model a real life situation. We'll also see what really happens when we look into variations for the same situation. Now, these variations can be related with transformation of functions. So, the whole concept of how do we model applications with exponential functions will be absolutely clear at the end of this video. Well, in case you want to learn from me, you can always send an email on the address given. Let us try to understand the question and its variations before we begin with the solution. Three students are initially infected with viral infection. We'll call this as day zero. Each of these three infect two others who become ill on day one. So on day one, we have 3 times 2 additional persons affected by the viral infection. Each of these then passes on the virus to two new students on day 2 and so on. So every student passes on the viral infection to two more each day. That is the situation. Of course, this is an exponential growth, as you can see in the number of people being infected by the viral. Okay, so the question here is how many students become ill on day 3 and day 5? Write a model for this situation. How many days would pass before 850 new infections are reported? So that's the first part of it. We'll try to understand this particular question's solution in details, right? And then we are going to look into the variations. So what I've done here is that same question, we could write this as S students, right? So in general, number of students could be, we were saying 3, it could be S students are initially infected with viral disease. Each of these S infect N others, right? So who become ill on day 1, each of these pass on the various virus to N new students on day 2 and so on. So you see the variation. The number of persons infected on the starting date and the number of persons who get infected from these, we could call them as different variables S and new, right? So, and then based on that, we have 3 different situations. The very first one, as I said earlier, is when S initial number of infected students were 3 and the new ones they are infecting are 2 each, right? So, and now we'll take a variation when what happens if the number of infected students are not 2 but 5, correct? Or if we start with not 3 but 10 infected students who are going to infect 2 others. You understand the question now. Perfect. So let's now begin with the solution, right? With the case 1, which is 3 students are initially infected on day 0, each infect 2 others, right? So in short, I'm writing initially to start with, we have 3 students which are infected, right? So what we can do here is make a table of values to begin with and understand the concept. So in this table of values, we can write down the students infected each day, right? So let's say day starting with day 0 and infected students, right? Infected numbers. So on day 0, we are starting with 3, and on day 1, you see these 3 infect 2 each. It means 6 more will get infected, so we have 3 plus 6, and so the total number will now be 9. And on day 2, now what happens is that now we have 9, and these 9 will infect 2 more each, right? So 18 more. You get the idea. So we have now total 9 plus 18 infected, which is 27, and on day 3, 27 are already there, and 2 more. 2 times 27, that means, right? So 2 times 27 is 54, will get infected, and total will be 81, and likewise it is going to grow. So we have answered was first part of our question, if you remember, was on day 3 how many will get infected, right? So day 3 we have 81 infected. We could actually continue this table to find others. So 81 plus 2 times 81, double, right? So 2 and 8 is 16. We could add this up and find our answer. So 2 plus 1, 3, and 8 and 6 is 14, 4 and 1, which is 243, correct? So that becomes the number, and on fifth day we begin with 243, and then double will be infected, which is 486, and when you add them up you get 6 and 3 as 9, 8 and 4 is 12 to 1 there, and we have 4 plus 2 6 and 1 7, 29 infected on day 5. Makes sense, right? So we figured this out. Now that should help us to also write down the exponential function. That is the part 2. We want to now model the situation, right? So now we'll model the situation. So you can see that each time what is happening. So from 3 we get to 9, and from 9 we get to 27, and then to 81, and then 243 to 729. So each time we are multiplying it by 3. See, times 3. You see? So we see that the ratio is constant, right? Ratio of increase, right, is constant. Ratio of increase is constant. You can also find the first difference and figure out the increase, right? So let's make this table of values to find the ratio of increase. That will be first difference, right? You could do that, right? So make one more table from here, and we can write down what is the first difference, right? First difference will be what? So first difference is 9 minus 3, which is 6, and then we have 27 minus 9, which is 18, right? And then it is 81 minus 27. So when you do 81 minus 27, it is 11. Take away, 4, right? So it is times 3, as you can see, 3 times 54, and then we could do this difference, and that will be 243 minus 81 will be 2, and 14 take away this is 162, and then this common difference will be 9 take away 3 is 6, 12 take away 4 is 8, and 6 take away 2 is 4. Do you see that? So as we see here, we see that each time the first difference is getting multiplied by 3, right? So definitely it is an exponential function, right? So let me come here now. So each time we see it is getting multiplied by 3. So times 3, correct? So definitely when we model the number of persons infected, so the number of persons infected will be related with 3 to the power of x, right? Now you will notice that if I do 3 to the power of 0, I get just 1, not 3, right? So if you see that, so we get 3 to the power of 1, this is right, not 0, and this is 3 to the power of 2. So as you can see, the number is being multiplied by 3. Or you can say that the model is 3 to the power of x plus 1. So either way, you could write your model. However, this particular model helps you to understand that on day 0, we have 3 infected students, and then the rate at which it is growing is times 3, right, each day. So that gives you the exponential function, right, times 3 each day. So if x is the number of day, we can use this formula to find the solution. Does make sense to you, right? So I hope you have understood how from the given situation we could model, right? So we got the solution where n starting number is 3 and two new students are infected, correct? And we found that this model basically was that the total number is equal to 3 times 3 to the power of x, right? Or you could write this as 3 to the power of x plus 1, either way, right? If you want to sketch this graph, how will it look like? Well, let's try to sketch this with the values which we had. So to begin with, on day 0, let's say this is 0, and then we have like 1, 2, 3, 4, and so on. We see it is a very small number to begin with. However, it is like very, very high, right? So it goes kind of like this, right? So this diagram is not to the scale, but we know these values rapidly increase, correct? And you can pick up the values from the table which we have shown here. So the number is 3, 9, 27, 81. So as you can see very clearly, these numbers are 3 to the power of 0, and this number here is 3 to the power of 1, right? This number here at 2, we have 3 to the power of 3, correct? You get the idea, right? So, sorry, this is 3 to the power of, this is 3, which is 3 to the power of 1. And here, at 3, we have the value, which is 3 to the power of 4, correct? So, one more. Or you could write either one of this. So, that becomes the graph of the function when here we have number of days, let's say d, and days in x, let me write down x since we use that in days, right? And here we have infected persons. So in numbers, right? So now let us take case 2 in which we start with 3 and 5 new are infected. To work this out, we'll follow the same procedure, right? Let's make a table and see what happens each day. So let this be the number of days. We say x is the number of days, right? Starting with 0, 1, 2, 3, and so on. And n is infected people. So on day 1, we are saying that we have 3 students infected on day 0, but on day 1, they infect 5 each, right? So it means 3 times 5, so which is 15, and when you add this up, you get 18, right? Now, on the second day, we have 18 from the previous day, and then 5 times 18. So 5 times 18 becomes 90, and adding 90 to 18 is 108. So on third day, we have 108 students, and 5 times 108 will now get infected, right? Additional. So 540 additional gets infected, and when we add this to 108, we get a value of 648. You see how rapidly it is growing, right? So on day 4, you can again do the calculations with 648 plus 5 times 648, right? 3240, and then to this add 648. Clear. So now, if you find the first difference, what do you get? Well, you see how many are getting infected, right? Which is 18 minus 3 is 15, right? And then 108 minus 18 will be 90. And then this minus this will be 540 additional infected, correct? And then we have 3280, right? 3240. As you can see from these numbers, they are actually rapidly increasing. And you see the ratio 90 by 15 is 6, correct? And this ratio 540 by 90 is also 6. So we are going rapidly with 6. So this is an exponential function. Base is 6. You get the idea. Exponential function with base of 6, correct? So how do you write this particular equation? Well, initially it is 3. So 6 to the power of x, if I write like this, then I get what? I get 6 to the power of x as equal to x when 0, I get just 1. But I need 3. So I have to multiply this by 3. You get the idea. The initially effective. So this particular ratio is the base, and 3 is the starting number. And that is how we can actually form our model. I hope that makes sense, right? So we can write down the equation very easily as number of students infected is the initial number n0, right, times the rate to the power of x. This makes sense, right? So in this case, since we started with 3, the ratio is 6 to the power of x. And that is how we can model this particular situation. Makes sense, right? Now, here is case 3. We have s as equal to 10, right? Starting number is 10 and number of new students infected is 2. In that case, our model should give us what? We said model is n0 times the ratio, right, to the power of x. Now, how do you find the ratio? How do you find the ratio? Correct. So you could actually take some values or estimate from what we just did. Correct. You get the idea, right? Since 2 are being infected by all, the ratio is 2 plus 1, which is 3, right? So the ratio normally relates to this number. If you go back to our second example, we see that new infected was 5, right? And therefore, the ratio was 6. Do you see that? So in this particular case, we have the ratio should be equal to new infected plus 1. And therefore, you can check your result that n should be the starting number 10 times 2 plus 1, 1 more, right? 2 more than 1, right? So it is 3 to the power of x. And that becomes the model for this particular situation. You get the idea. So I hope you have understood the process of how an exponential growth in such cases could be modeled. Well, feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. In case you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.